Turn it over to Greg. I got it.
Okay, folks, I'm going to introduce, just picture yourself introducing the smartest guy you know. Can you hear me? Can you hear me okay over there? All right, awesome. NJ2US is Jeff Doran. He's a lifelong family friend. Jeff is seriously one of the smartest guys I know. He is a mentor. He is an Elmer. He is the go-to guy when you need something technical solved, or in Jeff's case, he's a good family friend. He was 30 years as a police officer, captain up in Brigantine, New Jersey. So if I need a counsel there, I could find counsel there. But Jeff has been he introduced me to Punta Gorda, actually. We flew down here. Jeff's a pilot. Before you know it, Jeff and I were flying side by side. Jeff is one of the most proficient instrument pilots that I knew. We'd go up in storms, rain, wind, and go flying. And Jeff, like I said, has we've been all over the area and everything like that. Let's see. He is a retired captain. He has quite, if you get a chance to look up NJ2US on QRZ, he has an antenna field. He has radios that are Apache level, Flex 6400. He has ICOMs, SDRs. Jeff will talk about, and I'll let him speak for that. But he runs the gamut from high-end SDRs to a low end. He probably doesn't have any dongles plugged into his USB ports, but I'm sure he can work with some questions about that.
I am going to stop sharing this screen so that he can share. Is that okay?
He is sharing.
Okay.
He's sharing.
Okay.
All right. And if the conditions are right, I will hand it over to Jeff. NJ2US. Jeff, can you hear me okay?
Brother Greg, how are you?
Very good, sir. Very good. We have your QSO card open. We can put you on screen and you can continue on with
It'd be my pleasure. Yeah, I'd like to share my screen. I think you're sharing my QSL card, which is coming from your end. So
yes.
Yeah, there we go. So I'll pop
You're
up.
on.
Yeah, let me pop up my screen here. And in my I'm still gainfully employed, even though I retired from law enforcement. I'm still working essentially what amounts to be a second career in the Homeland Security communications field for a company based up in Wallingford, Connecticut. First of all, can everybody see this screen? Earlier, I had a problem with Zoom. Can you see the title slide with a iPhone showing some SDR software, remote control software? Can we see that down there?
Sure can.
Great. That's awesome. Well, first, let me correct the record. My dear friend Greg, who I love as a brother, and I've known him a very long time. We've been through some crazy things together, flying probably the least of it. But when Greg announced to me some time ago that he was moving to Florida, it was an honest heartbreak to lose a buddy. But fortunately, we've been able to keep in touch with technology and even the occasional amateur radio QSO, which is very cool. But let me state for the record, I'm just a hack. I think when Greg views things I've done, he looks at them as these great accomplishments. I just look at it as a guy just trying to figure stuff out. So I'm really not unlike many people in there. And with that little disclaimer, perhaps I'm being a little humble, but if you'll just indulge me, my knowledge of software-defined radios was really just something because it was fascinating. And I don't presume for 1 minute that there's nobody else in the room there or on the call that doesn't have a similar or perhaps even a more advanced experience with software-defined radio technology, perhaps. So it's not going to be my goal here to try to teach anybody anything, more just sharing experiences of what I've learned over the past decade or so in moving from analog radios into the software-defined transceiver category. And we'll do this by way of just a brief agenda. Again, the goal here is not to go past 25 minutes tops, 30 minutes tops. Plus, if anybody has any questions, I'll try to help out. I can tell you of all my hobbies, though, amateur radio is right up there. Of course, it is something that I enjoyed from getting my novice license in 1971 at the age of 12, and then just continuing in the hobby throughout my entire life, my career, raising a family, working 30 years on the job as a police officer. There was never a time where I did not have a shack with ham radio equipment in it. Times for operating were sometimes limited, especially in raising the children. That, limited my time, but I always felt near and dear to my ham radio roots. But I shared an equal amount of time, if not a little more time, with an absolute passion for aviation, and pursued my flying enthusiasm in the early 80s, got my private pilot license in 1986, bought my first aircraft in 1994. That was, for those of you that are aviation oriented, know anything about airplanes, and Greg certainly knows, he's flown with me many hours in my Mooney. I had a 1982 M20J. I owned that aircraft for 24 years. I finally did sell it a few years ago because I had to make some tough decisions about engine overhaul, engine replacement. As you can all imagine, nothing about that got inexpensive as the years went by. So I had to make a tough decision to sell the airplane when I could still get some value out of it without having to sell an airplane with what's called a run-out engine. So here's what we'll talk about. So there are some basic differences that we need to understand about SDR versus super heterodyne radios. Many of you grew up with super heterodyne radios. These are purely analog radios, many of them with point-to-point wiring, use of vacuum tubes, later transistors. But with the advances in large-scale integration circuitry and the unbelievable inventions of things like FPGAs, the floating point gate arrays, which are absolutely remarkable and allow computers to process instructions millions of times a second and allow us to do things that are really become very amazing and somewhat scary. And I'll point that out a little bit, and I'd like to see your reaction to one of the things I want to show you here. So when we talk about SDR versus super heterodyne, let me move this. By the way, that iPhone 14 there is actually running a smart SDR software that is talking directly to my Flex 6400. I run that radio 24/7. It allows me to log into it and operate from the iPhone, which is cool. And again, I'm not saying that anybody in the room doesn't know about this. If this is a surprise to you or this is exciting, then I'm glad to show this to you. This is not new technology, this ability to remotely operate your radio. But what is cool is the ability to see the pan adapter and the waterfall displays on these things. Very cool. I also have in the shack, as Greg mentioned, an ICOM 7610. That is my proverbial radio with knobs. It's a great backup radio, and there is equally available software written by the same fella, by the way, that wrote this software for the Flex equipment. He writes software in addition for the ICOM 7610, and it looks very similar to this display. The super heterodyne technology, of course, is something that's been around for a long time. And the whole idea behind super heterodyne is just that, heterodyning. When we combine two signals, we end up with other products, and then we can refine and filter those products, demodulate them, and eventually, when we're talking about receivers, they come out of the speaker as signals that we can understand, starting with CW signals, which were simply carrier going on and off, right up to amplitude modulation, more advanced modulation techniques. Single sideband took the world by storm. Perhaps senior operators in the room might even remember a time where they referred to single sideband as that newfangled single sideband. So it really did revolutionize radio and allowed us to kind of get more energy concentrated and be able to propagate signals. And of course, where are we now in the sunspot cycle, right? I think many of you may have been waiting for the sunspot cycle. We're on the upswing of cycle 25. I waited a long time for this, actually prepared for it in my entire hamming career. I seem to have missed all the sunspot maximas and never really got to enjoy them, whether it was work or family. Something always stepped in the way. And I found whenever I was getting involved in operating, I was during sunspot minima. So now it's great to get on 10 meters, Still waiting for those 6-meter openings, though. I don't know what you get down in Florida, but those 6-meter openings are still a little bit hard to find. So the super heterodyne, these block diagrams made for simplicity. The idea is that we use oscillators. Oscillators typically in semi-modern times, we use crystals to provide a stable frequency source to generate the frequencies that were put into the mixer. And we ended up with a product that we could listen to with our ear. And then we graduated into the software-defined technology world. Now, what's amazing about software-defined radios is that the theory behind the operation of this, although the equipment used is rather sophisticated, it's amazingly simple in design. The idea is that we employ a small device called the ADC, or analog to digital converter. Flex refers to these as spectral capture units. They decide to come up with their own term, but it is still just an analog to digital converter. And then the data that comes out of that goes into that floating point gate array, which provides all the functions of digital signal processing. Again, the end result is listening to a signal generally through your PC, laptop, or some other computer. And that's what really makes this probably uncomfortable for some radio amateurs. They're just not used to having to rely on a computer to perform the last function of being able to understand radio transmissions. But it turns out that the art of using a PC to process this using what is generally open source software, you could do some very remarkable things. And of course, if you use SDR dongles plugging into your USB port, obviously using SDR Uno and other types of software, it makes that tiny dongle come alive with incredible receiving capability. Now, there's some unique characteristics of the SDR design that make for some interesting capabilities. And one of the most important capabilities is the ability to capture large segments of the spectrum, of the RF spectrum, from low frequency 65 kilohertz on up to the gigahertz range. Of course, all of the communication services lie in there somewhere, and SDRs can be used to receive all of them. Again, the power is in the software, not necessarily the actual device. When we talk about SDR, though, the concept and the conversation generally turns to performance. How does the performance of an SDR compare to a typical super heterodyne radio? Now, examples of super heterodyne radios, and we'll draw some distinctions in a later slide here, determines to the vast amount what your understanding of the technology is. I will say that, and I hope you know this, and if you don't, let me be the first to explain to you, it is possible to have an SDR inside a radio with knobs, right? And of course, an example of that, I just gave it, that ICOM 7610, the 7300 are perfect examples of software-defined transceivers shoved into a box. And we'll see some pictures here. When you open them up, they look more like computers than they do radios. But they are, in fact, SDRs with a user interface bolted onto the front panel of the box, making you believe that you're still operating a radio with knobs, right? So I'm sure everybody understands that, but sometimes we just have to say it out loud. Now, let's talk about performance of these. I think, and most of you know this, maybe you don't, but one of the most recognized fellas in the industry is Bob Sherwood's receiver performance test. You can get this on the internet. This is an eye chart. Don't try to read that. I'll go to a slightly larger one here. And you'll see that the top 10 radios that Bob Sherwood identifies, again, we're talking about receiver performance here. Transmitter performance is a whole nother discussion we can have. Maybe even a later presentation, we can talk about where state-of-the-art is with transmitting capability. But you'll notice that for the most part, in the amateur radio space, generally speaking, super heterodyne receivers still can outperform some of the best performing software-defined transceivers. Now, the technology allows SDRs to actually outperform super heterodyne, but it comes down to cost to manufacture, the price of the components. You'll notice at the top of this list is the Yaesu FTDX 101D MP. That is a super heterodyne receiver inside that radio. And so they can exploit all we've learned about receiving technology and come up with the most important number in this chart. Now, the reason it's all the way over here on the right-hand side, this dynamic range narrow space, otherwise referred to as the reciprocal mixing dynamic range, these are how we rate radio receiver performance today. It's not necessarily sensitivity. Back in the days, we used to say, oh, my radio's got 0.15 microvolt sensitivity for a 10 dB signal to noise ratio signal. Now it's about how well do these radios perform when you use them in close-in operations, or in contests where you have signals that are very close to each other. SDRs can have a tendency to overload. That can be important too, so we have to watch those numbers. One curious thing about this chart, and I've always noticed this, if you follow Bob Sherwood and you watch a lot of his presentations, there's a chart he places up here, and you'll always notice that Flex Radio, the 6700, always seems to manage to end up at the top of this list. Now, there's some discussion about this, and I'm not knocking Jerry at Flex Radio, but it almost seems like he claws at the various people who measure performance to somehow make sure that his legacy radios end up at the top of these lists. And I'm not saying anybody's fudging numbers. I just find it curious how a radio that's more than 10 years old ends up at the top of this list every time. Listen, you never fault Flex Radio for being in the business and trying to exercise a good marketing technique, but they always seem to shove this 6700 up to the top of the list. One could argue that the performance of the 6700 has fallen off quite a bit. Now, what's interesting about this list is this is a mixture of both super heterodyne and software-defined radio technology. You'll see that at many times when the Kenwood TS890S was first introduced, it had some pretty good numbers. And I don't know what Bob does with these numbers, but it seems like these numbers change. But here's the great news. There's good news in all of this. And Rob Sherwood will tell you quite directly. He'll tell you, look, I create a chart and I resolve these numbers through the use of test equipment, starting with the best dynamic range of 110 dB. That's pretty cool. But if you look down at the bottom end of this, the ASU FTDX 5000, which, by the way, on the ARRL performance chart is actually number 1 compared to Rob Sherwood, he's all the way down here at number 10, has a dynamic range of 101 dB. Now, the good news, the takeaway is, if you own any radio in this top 10, you are not going to be able to tell the difference, at least from a performance standpoint, that any one of these radios is any better than any other one on this list. This is just a numbers game. This is just a numbers game, because to the human ear and to the casual operator, the difference between a receiver with 110 dB of dynamic range compared to a radio with 101 dB of dynamic range, you're just not going to see it. You're not going to hear it. And unless you got the right test equipment, you're never going to see these numbers. So this becomes more of a marketing tool than anything else. Not knocking the procedure, but that's good news. The good news is that receiving technology has gotten so good that we've basically reached the plateau of sensitivity. We're already there. The noise levels that we experience every day are far more than the received sensitivity capability of all the modern radios. The general rule of thumb, though, is that if your SDR has a dynamic range of generally 100 or better, say up to 110, it's generally considered to be a top-notch, top-of-the-line performance in those radios. Let me talk about something I mentioned a little bit earlier, and this is one of the capabilities of SDRs that is a little, I'm not going to say it's frightening, I just said that for effect, but the fact that I can capture a large segment of an HF spectrum measured in megahertz, and then I can actually deduce from that what's known as the IQ signal stream, the in-phase and quadrature components of a signal that's been translated from analog to digital. It means that I can store it as bits, as zeros and ones in a file. Now, think about the complications of that and what the implications of that are. That means that I can set up an SDR receiver that, say, is listening between 6 megahertz and 8 megahertz. And I record that IQ stream to a disk file, and these files do get quite large. I can, in fact, at any time in the future, reload that IQ file and play back everything that happened in that frequency range for the length of time that I recorded. So yes, and what some people do, and if you search the internet, you can actually find fellows who've recorded all large spectrums of the HF bands, particularly during a contest. And you can actually go back, set your SDR receiver up to retune those segments that you recorded. So you could listen to one transmission at 10 a.m., rewind the software file, listen to another QSO at 10 a.m. In other words, they're all happening at the same time. The implication of that is, what if the government did that? What if the government is right now today recording large chunks of HF spectrum? And if they needed to go back and review something of what happened, say, 15 days ago on 7,200 kilohertz, they can do it. They can rewind their software back to such and such a date. They can tune their SDRs to a certain frequency, and they can hear everything that occurred on that frequency in time without knowing about it. So that's different than having a recording of the frequency. That means they can go anywhere. So that's kind of cool, but scary. And I think we're pretty naive to think that somebody isn't somewhere capturing large segments of the HF spectrum all the way from low frequency to very high frequency. Just something to think about. I'm not a conspiracy theorist. I was a cop for 30 years. I was more concerned about speeders. So, but just a thought of what you can do with SDR technology. Now, what does this mean when you open up a radio? Here's a quiz. Anybody in the room, can you tell me on the left-hand side, I have the cover off of a transceiver. Does anybody recognize the inside of this radio on the left-hand side? Well, that is a KWM2. One of my prized possessions is a KWM2. I revere that radio. As Greg remembers, we grew up in the Philadelphia area. We used to go to the Franklin Institute in Philadelphia, and they had an amateur radio club station set up right on the main floor. And as a punk 11-year-old, I'd go up there and press my nose up the glass as that ham radio operator was behind her operating a complete Collins S line. And I always told myself when I was 11 years old, that's what I want to do. I want a radio station like that. Pretty amazing. To the right of that is the inside of a Kenwood TS2000. Again, you can see the technology's come a long way. We've gone from vacuum tubes to transistors. And now if you look up some of these more modern radios, this is the inside of an ICOM IC7300. You'll see here the Altera FPGA, one of the major components of the SDR. But again, the inside of these radios look more like computers than they do radios. So something just to think about where we've come with the technology. A lot of you may know about the SDR Play, one of the rather more inexpensive devices that is a very capable unit. Not much to it in terms of what the circuitry is, right? You have the RF input, the USB providing the serial data that goes to the software, which is really where everything is happening in your PC, where you do all that. But these things are really inexpensive. This is kind of similar to the dongle SDRs that many are familiar with. You can get them very cheap nowadays. And they really are a lot of fun. A lot of fun, especially if you're into software listening. So I wanted to just pull out some other differences where the state of the art has come. And most of you know Bob Nagy, AB5, and he was the guy instrumental in coming out with that microphone modification. He became famous when he was able to fix the ICOM IC7000 mobile radio, the horrible audio that came out of that radio. He had a microphone mod. Anyway, Bob Nagy has gotten heavily into SDR technology. And this one's for those of you who may be wondering, what's the difference between that Yaesu FTDX10 and the FT710? So, and a lot of people say, well, why did Yaesu come out with two different radios so close to each other? They made some improvements, but there is a basic difference in these radios. The FTDX10 is actually what we refer to as a hybrid. The front end of this is actually super heterodyne. There's a mixer, there's a low noise amplifier, the RF preamps, a filter, and then it goes into the analog to digital converter where a lot of the processing takes place. The newer radio, the 710, is truly a complete direct sampling software-defined transceiver, just in case anybody was curious that. It comes up in conversation, like, what's the difference between the 10 and the 710? And a lot of it had to do with the cost of components. Just wanted to throw that in there. We're going to wrap up. This, again, wasn't meant to be a long presentation. We can speak anecdotally about where we are with this technology, especially in the marketplace. This screen capture is basically the interface I use on a daily basis as I operate. I'm a big-time net controller on the East Coast Amateur Radio Service. Down your way, you have South Cars on 7251. Up my way, 7255 E-cars, East Coast Amateur Radio is East Coast Amateur Radio Service is huge, and of course mid-cars on 7258. This is the Theta software. This software is free. We have developers who are constantly working on it. We have very talented programmers. They all do this out of the goodness of their heart, and they share this software freely with anybody that wants to download it. And as you can see, it is on your PC screen. And I know that turns some people off, but for some of you, this is pretty exciting stuff. So if you ever get the opportunity to actually explore SDRs, there's no reason you can't have a knob with radios, maybe an old traditional analog radio. But by all means, I think the future is going to create an environment where, you know, we're going to be using the software-defined technology, but we'll probably never get rid of radios with knobs. We're always going to have them. But if you really want the true flexibility, when you start using your computer as your radio, it can be a little intimidating. Think back to the days if you were an AM operator and you tuned across your first single sideband signal. This is something like that. So very interesting stuff. I appreciate your time. And I showed you earlier, I'll just put this back on the screen. What you can do with SDR radios, you can run them on your smartphone, your tablet, your laptops. You can take it on the road with you. You can operate mobile with these. In fact, you'll hear that a lot. You'll hear a lot of mobile operators check in mobile. I'm not really crazy about that. They'll sign as a mobile, but in reality, what they're doing, they got their smartphone connected to a cell phone tower, connected to their kilowatt back in the home shack, and they're checking in as a mobile. We all love that. So I really appreciate that you guys gave me a little bit of time here. It's a lot of information in a short amount of time. Maybe it spurs some discussion. Maybe it puts you to sleep. But in any event, I hope you enjoyed your cookies and your coffee. Back to the room.
Jeff, I'll throw a question at you just to add on if anybody else has any questions. But I wanted to know, you know, it's easy to get an SDR radio. You can get them for $30 on Amazon, or you go upscale and pay $100 some for the Air Spy, I think it is, right? So when a person wants to get involved, if they have their tech license or pre-licensing, and they go buy one of these $99 radios, what's the best antenna to throw up in the air to listen? I know you have quite an antenna farm, but I know you didn't start there.
Great. Thank you, Greg. I appreciate the question. So yeah, antennas are always important. So, you know, I think, you know, antennas can be approached in a couple different ways. If you have a frequency range of interest, by all means, always try to put up a resonant antenna. And that's not just for transmitting. Let me explain what I mean by that. Many SDRs, one of the things that cheaper SDRs suffer from is overload, ADC overload, where too many signals are arriving, especially when the conditions are really hot. That ADC gets overloaded and you end up with birdies and other products that appear throughout the spectrum. You might be tuned up to 6.5 megahertz trying to tune in a shortwave station, but you actually hear your local AM broadcast station that might be on 1040 AM. And what's happening there is the front ends of these SDRs are overloaded. One of the ways to combat that is to use like a resonant dipole, 2 or 3 of them, where you can set them up in particular band ranges. Now, this is for the serious guy who has the room and the space to put up. If you really want good overall coverage for an SDR, I would suggest a 40, or if you can figure it out, maybe an 80-meter dipole. Center feed it with some RG70, RG6 or RG58, or, you know, RG213. Don't even need 213. That's for higher power for transmit, of course. And what actually happens is that antenna, if it's resonant at certain frequencies, it will act as a bandpass filter that will actually help limit some of those stronger overloading signals that tend to swamp the less expensive receivers. If you just want to throw something up and you're not too worried about it, any end-fed antenna is perfectly fine. And the way you properly construct an end-fed antenna is you can use a 9-to-1 un at the beginning and maybe wind out about 73 or 103 feet of wire, and they can perform very well. But you got to remember, if an antenna has wide band coverage, if it's a multi-band antenna from 160 to 10 meters, you're going to have the same problem with overloading because the antenna can't discriminate. One of the other ways is if you feed any wire antenna with a standard antenna tuner. Any ham radio antenna tuner can act as a poor man's bandpass filter to help reduce the incoming overloads into that ADC. Because as you tune an antenna tuner, you're selecting a combination of capacitance and inductance that limits the signal strength coming in. And you can find that that will help eliminate some of the drawbacks to these very inexpensive dongles and SDR plays and the like.
Okay, I have another question. Roger?
He mentioned the 7300 and the 7610. Have you extensively modified the SDR software within those two radios?
No, and here's one thing about ICOM that I think a lot of people might be a little chagrined about. So I bought the 7300 transceiver when it first came out, when it was first listed for around $1,500. I think it had been on the market maybe a month or two, and I bought it and I loved it, and I should have never sold it, but I did. And then bought the 7610, and that's what I have now. But no, I've never made an attempt to go in and change any of the firmware or any of the software that's internal to the radio. I suspect some pretty good folks maybe have gone in or tried to do that. But, you know, again, the thing with ICOM is they have, you know, they released 2 or 3 upgrades to the firmware to those radios, but the 7610 now, I don't think there's been an update in a few years. And quite frankly, I don't think we'll see any more updates to it. So no, I've never physically gone in and tried to manipulate the internal software of an ICOM product.
Thank you.
That's one of the advantages of the open source software that you can use with some of these things. For example, that Theta software that I was showing you here, the source code to this software is available to anybody that's willing to download it and has any kind of C+ or C# programming experience. You can go in and change this software to do anything you want. However, the fellow that wrote this, Dr. Warren Pratt, NR0V, this guy created all the libraries that drive this software. And one of the things you'll hear about the Apache Lab series of radios and the HP SDR software, Thetis being the latest version, it has incredible noise mitigation capabilities. Some would argue best in class, best in industry, even rivaling the Flex radios and even the ICOM radios and even the newer Yaesu radios. That's something for discussion. I'm just saying that there's this radio does have kind of a cult following, but if you do know anybody that's using Thetis on an Apache radio, they sound great and they have super receivers.
Dave, I have another question.
Yeah, related. Is SDR Uno the best software to use with an RSP?
Yes, in one word, highly recommended. It's a very well-designed piece of software. And in some instances, if you look around properly, you can actually use different software with the SDR play and some of the other SDR receivers, because they all have a basic same design. But yes, SDR Uno is a top-notch piece of software. Of course, it's free. I've used it. I like it. And I don't have any complaints about it. Now, look, there'll be some people who have millions of complaints about it, right? Because they're trying to compare it to something else. But the price is right, and it's a super performing software for a very solid piece of hardware. Absolutely recommend it.
What do you think of SDR console?
SDR console, it is actually, it does not perform as, the problem with SDR console is the guy that writes that really wants to marketize it. I think his goal is to make it something he can sell. Again, a very nicely written piece of software, but when you use it with, say, for example, Apache Lab equipment, it does not fully support all of the feature set of that transceiver. For example, the adaptive pre-distortion, the ability to clean up the third order IMD products in a typical transmitter. SDR console is not capable of that. So we got to remember, we're talking about really two different things, right? So for many people, we're really involved in listening to software that's controlling our receivers, but full-featured SDR software does both the receive and the transmit function. But yeah, I try to experiment with as many of them, and that's perhaps the coolest thing, right? Number one, they're all free. They're simple downloads. And if you're really good with your PC and your operating system and you understand networking, you get to experiment with all these things for practically nothing. And that's probably what the real beauty of that stuff is.
I had a problem getting Thetis configured with a Hermes Light 2.
Hmm.
But I could get SDR console configured.
Yeah.
And then,
Yes.
yeah. And
There's
then,
a fellow that's writing that has the Thetis source code, and he has developed a piece of software that is exactly the same as Thetis, but it's written specifically for the HL2. I'll send that to Greg and he can get it to you. If you email this fella, he's a G0, he's a Brit, but he will gladly, he's a Hermes Light fan, and he's modified the Thetis software in a way that works fantastic with the Hermes Light 2. And he doesn't publish it anywhere, but if you send him a simple email, he'll send it to you and you can try that out. You might have some great success. I've talked to a lot of fellas on the air that are using, I just can't remember his call. His name is Steve. Maybe this rings the bell for you. His name is Steve and he's a G0. Just can't remember his call off the top of my head.
yeah, I can't remember the piece of software that I've used. It's got the FT8 client in it already. And then CW used both of those, but I just can't remember what it was. I'll play with it, then put it aside because it'll stretch your brain a little bit messing with that.
But let me tell you something. At HL2, the Hermes Light 2 is a very capable SDR transceiver, of course, with transmit capability that is very good. Now, I don't know if you've tried the latest version of Thetis. I've been told that the latest Thetis 2.10.3 has better support for the HL2 because there was some collaboration between Richie, MW0, LGE, and Steve, the G0, and he brought some of that code over. So
I think Maker Fabs has those things with a case now for maybe a little over $300.
That's right. It's a fantastic deal with the case, absolutely, and they are cooperating. You hear more and more on the air. If you got one, that's great. Keep hanging on to it because there's a growing audience for that combination of transceiver and software.
Yeah, I've got one of the first ones, and then they call it a kit, but it's really not a kit. It's
now, do you operate it QRP or do you drive an amplifier with it?
I have done it both ways. I've done QRP with FT8, and then a fellow on the list was selling an interface for a Hard Rock 50.
Yeah,
and I've done it with that too. It works great with a Hard Rock 50.
Yeah, and then of course, what some people do, especially if you use the adaptive pre-distortion component, you can then drive a bigger amplifier, and still you will have a very super clean signal because one of the advantages of those receivers, including the HL2, is its ability to what Apache calls pure signal. Is actually a version of what's known as adaptive pre-distortion, which is used worldwide in mostly all communications technology. Not in ham radio, though, because there's a lot of dirty signals on the air. But if you see an Apache signal on the air, you'll know it's Apache because it's got the railroad track cutoffs on each side of the passband.
All righty. Jeff, maybe one of these meetings, I will have Jeff represent Mutual Link. Mutual Link, Jeff was a director of emergency management also up in New Jersey, Brigantine, and he wound up with a company through some transition called Mutual Link that combines through 9/11 and some of the catastrophes that we've had in the world with the similar radio frequencies when EMS is coming in, the fire department's coming in, police, with security guards, with FRSs, video cameras that have audio capabilities. Mutual Link will combine all of those frequencies together to one frequency that somebody can listen to exactly. And Jeff, you can give a short on that, but that's basically what Jeff does right now.
Yeah. So what MutualLink does, again, it's not meant as a commercial. Greg brought it up. I wasn't going to mention it at all. But what we do is we provide a government and private sector interoperability capability that essentially how we use it up in Greg's old vicinity here. In fact, his old workplace is on this map. What we do is we provide interoperability where the casino industry in Atlantic City, this is just one small example, can link their video and their radio comms and interoperate directly with law enforcement agencies, including the New Jersey State Police and Atlantic City Police. So from an app, they can view any security camera at any casino, and they can have two-way communications between a trooper and Atlantic City police officer can talk directly to a security guard in any of the casinos in Atlantic City. On a larger model, we actually have a pretty big presence down in Florida, where we have another product where we do panic buttons in schools. Same thing. So in Florida and in the schools, if you push a panic button in one of these schools, the first responder agency, the 911 agency, gets a floor plan that pops up And also they get to automatically have access to the pan, tilt, and zoom of every single camera in the school, and also provides instant two-way communications with the school. And all this is happening in the first 15 to 30 seconds of a panic situation at the school. And hey, with the way things are nationwide, dealing with active shooters and armed intruders on campuses, this has become a very big deal for us. In fact, you'll notice over here on the left-hand side, the state of Arizona has put the MutuLink technology in every single school in Arizona. You can see there's just hundreds of agencies here. Yeah, Greg, I'd love to talk about this. It might be, to the radio amateur, there's application here, and it is fascinating. So thanks for the plug.
Very good.
Awesome job.
All right. I think that will close it out for us.
Oh,
Will you have copies of these slides on the?
Yeah, we're gonna try to post it on Groups.io, or we'll edit the video. And, absolutely, yeah, we'll have the information out there in the video.
Thank you.
This presentation was recorded, and you'll be able to rewatch this video on YouTube, right?
Yeah, we'll put it.
If you get it to me, I can.
Yeah.
We'll get it up.
Thank you very much.
Very good.
Jeff,
Jeff,
thank you.
awesome job.
Well, thank you, gentlemen. I really appreciate it. I don't know if there's any ladies in the room, but thank you so much for your time. It was fun. When Greg asked me to do this, I was a little bit nervous. I almost felt like when talking about SDRs, I'm a little bit out of my element. So I hope there was some tidbits of information that somebody was able to walk away with. It was sure a lot of fun putting it together. Have a great evening, fellas. It was really nice meeting you all. Hey, we'll see you at Orlando at Hamcation. The wife and I will be down there. Greg will probably be
Oh,
there.
that's right.
All right.
We'll be there.
All right.
Thanks,
Barbecue's
Jeff.
on us.
Take care. Thank you.
Very good.
So I have a question. How many people have SDR radios here?
Sure.
How many people have SDR radios?
Wow.
Not now, let's discount, like the ICOMs and how many people have anyone here have an Apache? I know he's got a Flex. Is that the only Flex in the room? Anyone else have a Hermes Light? No. Anyone have dongles?
RSP, yeah.
Yeah, Air Spies.
Air Spy.
Yeah, what's the other one? RTL, RSP, yeah.
RSP, that's what.
Yeah. Yeah. So, I mean, if you want to stretch your brain, and I know he doesn't like console, but you can adjust everything on the radio. I mean, you'll spend so much time. If you don't want to spend time, I mean, Thetis is pre-configured. That pretty front end is pre-configured on Thetis. So it looks like a radio. You're pretty familiar with it, but it's an adventure. I've hooked mine up to my 2.70 m antenna. Pretty interesting. I've used a coaxial loop and just let it run to see how many countries I can hear in a 24-hour period. Blow your mind. Yeah. On FTA.
Be a demonstration.